discuss this, what we discussed yesterday. Let's show you here, that's it. I think so this Adyasha, Varsha, this two, I think so you have done 2-3 times this revision, this chapter, right?
Yes, sir. From starting we were there.
No, yeah. We did already almost 2 times, right? 2 or 3 times.
Yes, sir.
So by this time you might be by hearted all these topics. Okay. So if again those who joined today, I'm giving you a quick brief of this. Electrostatic. Okay, there are 2 types of charges. What are they? Positive, negative. And how to make positive charge? By removal of electrons. Once electrons are removed, it will be positively charged. When someone gain electrons, that will be negatively charged. Properties of charges: they are additive in nature, they are conservative, they attract repel, and quantization of charge, that is Q equals to NE. Product of number of electrons and charge of electrons. Coulomb's law, it states that force is directly proportional to Q1, Q2, product of charges, inversely proportional to square of distance between those 2 charges. So if we combine this, I'll get one K constant. What is K? Coulomb's constant. So value 1 by 4 pi epsilon naught, which is 9 into 10 to power 9. What will be the unit of K? Varsha, what's the unit of K? Yes, Jafar. What's the unit of K?
Newton meter square upon Coulomb square, I think so.
Yes, sir. Very good. Coulomb square. Okay. Coulomb's law in vector form. If there are 2 point charges here, 2 charges Q1 and Q2, okay, at distance r apart, so force on Q1 will be 1 due to 2, and force on Q2 will be 2 due to 1. So the force 1 2, force 2 1. It's in vector form, so they both are equal and opposite. Force 1 2 and force 2 1, they are equal and opposite, so they follows Newton's third law. Principle of superposition. What is principle of superposition? Jafar? Okay. Adisha? Do you remember?
Sir, if the system of if the system contains so many charges, so the vector sum of that system will be the total net force on that.
Yes.
Exerted by the remaining charges on that.
Yes. Yes, Jafar, you are about to say something?
Yes, sir. If there are n charges in a given system, then individual forces acting on each body will be the its resultant will be individual forces, sir. We can
Yeah,
take
sum
it as
of all.
individual forces and add it up.
Exactly. So if the system of charges system contains some charges, then the force on given charges is equal to vector sum of all the charges. Force F1, F2, F3, we are summing it. Others, are you able to understand, right? G1. G1, are you there with us? Somewhere else typing. Mr. G1, right? Johan?
Sir,
Yeah, are you able to understand what I'm saying here, all this?
I'm missing the context, not understanding that deeply.
Yeah, this what we are studying, it's basic only. Okay. What about Anjali?
I understand, sir.
Your voice was like not confident. What happened? You're not understanding, or a little bit?
We're like in school, we were sort of done with this chapter, so yeah, so I understand it.
Okay. Cool. So, Johan, which part did you understood? Tell me. I think so. These properties are simple. You know these properties, right? And this formula also you know. Okay, Q1 by Q2, it's similar to gravitational form. This is vector form, like you're finding in Coulomb's law in vector form. So for this, R cap 21 will be equals to R vector 21 by R. Okay. What does this mean? Like force on Q1 is F1, force on Q2 is F2, force on Q3 is F3. Okay, so distance from origin to Q1 is R1, from Q2 is R2, from Q3 is R3. Positional vector. So what are we doing here? We're finding a force on particle or charge Q. So it's for Q1, distance will be those two. For Q2, distance will be related to that Q2. Q3, distance will be related to R3. Here R2, here R1. So your total R is R minus in vector form. Let's see that. This all are principal superposition. In short, what we are doing, we are summing all the forces. We are finding first individual forces, F1, F2, F3. We are summing it all. So in simpler way, how we are writing this in common way, QI. I is that I1 to N numbers. So QI. So QI, let's take I as 1. So Q1, Q1. So here it will be Q1 by R minus R1 cube. Same way R minus R1. Similar way, if you find for Q2, it will be for R2. If you find for Q3, it will be for R3. till n. So all these I, we are adding it up, we are summing it up. We're summing it up as summation of fi. Now summation means summing it all, vector sum. So when there is a vector sum of fi, we need to just include I term. Remaining term should be constant outside. This q is constant for everywhere. Q, q1, q, q2, q, q3, and q so on till I equals to 1n. So how many, whatever charge we have, I took here 3, so let it be 3, let it be infinite. It doesn't matter. Now we have I means summation of I, q, I, r minus ri. All these items in summation. And I is 1 to n, and summation is vector sum here. So continuous charge distribution means integration, integrating. So as even the same thing I said yesterday also, as we are just finding a continuous distribution, that means we integrate. If it is normal calculation, normal thing, we can find out. But if it is a distributed load or distributed charge, then we need to integrate. We cannot find simply. Okay, so here same formula we are using with integral. Instead of summation, we have here integral format. So here we are using dq as lambda dl for charge, linear charge distribution. For surface charge distribution, we will use dq as sigma ds. What is sigma? Charge per unit area. Here lambda is charge per unit length. Same formula, we are just different usage. For linear charge distribution, we will use lambda dl, charge per unit length into length. Now, for surface charge distribution, we will take sigma ds, charge per unit area into area of element. ds is area of small element, dl is length of small element. Now, for volume charge distribution, we'll take rho dv. So rho is charge per unit volume into volume of element. Till here clear? Johan? Yes, Johan, I couldn't hear you. You said something, but I couldn't.
No, sir, I didn't say anything.
Achha. Okay, then. Okay, then electric field. So what is electric field? As we discussed yesterday also, a region around electric wire or electric things, anywhere. A region. Now, electric field intensity is given by force per charge. force per unit charge. Electric field intensity of electric field is given by force per charge, F by Q. Now, what are the properties of electric field lines? This starts from positive, ends at negative. Starts or ends at infinity for single charge. Continuous curve, never cross each other. These properties, I think so everyone know these properties. Varsha and Adyasha,
Yes, sir.
are you both getting bored or with this topic? Because we already finished almost exam questions also. And again, we are going back to basic.
Yes, sir.
But are you getting bored with this topic?
No, sir. It's a revision for us.
Acha. Because we already finished exam questions also. We didn't start our JEE questions. We just did some normal exam questions. Okay. Fine. If you're not getting bored, it's good then. So properties are important, as we know. They never cross each other because there cannot be two directions at a single point. Okay. And this point is not that important. They all are equidistant. Now let's draw some equidistance point.
So won't it be equidistance and also equal magnitude?
Equal magnitude, kind of, we can say yes, but not exactly. Let me draw those points, like you can draw that. If there is a positive charge here, same drawing, yeah. If it is positive charge here, what will how magnetic electric field line will form here? Inward or outward? In Jafar, you were also there for all the classes, right? Almost. Jafar, can you hear us? You got disconnected and connected.
Yes, sir.
You were there for almost all the classes, I guess so.
Yes, sir. Yes, sir.
Okay. Okay. So draw for this one. What you'll get here? It will be inward or outward?
Outward.
Yes, it will be outward. If I draw for negative, then it should be inward. Inward. Now, similar way, if I join this plus and minus, if I bring these two charges here, positive charge and negative charge, so they will attract, obviously. So attraction force will be happening here, like they will get attracted. So draw for this one. Done drawing?
Yes, sir.
Okay. G1?
Sir.
Yeah.
Sir.
Draw for this one. What will get here? One is moving outward, one is moving inward. So how will it form attraction? Draw it. Johan?
Yes, sir.
Drawing it. Now asking, are you drawing?
No, I actually didn't get how to draw those diagrams.
Okay. Then let me draw it. So one is moving outward and one is accepting. So one, it will be formed here because they are attraction force. Again, it will be formed here, attraction force. There will be infinite number of lines because these are imaginary lines only. Now, if I bring here two positive charge. Now tell me, Johan, will you be able to draw this one? Johan? No internet, joining, leaving. No. Jeevan, what about you?
Sir, I'm drawing, sir.
Are you able to draw for second one also?
Yes, sir. Yes, sir.
ठीक है. Johan, did you join back?
Yes, sir.
Are you facing some internet issue?
Yes, sir, a lot.
Okay. So this is for attraction, right? Because they both are opposite charges. Now, if they are same charges, like charges, then they will repel. So how will you draw for repelling? If both are positive, that means what you'll do here, because both will go outside, outgoing, and negative charge incoming. So both are outgoing, then what you will do?
Sir, done.
Outwards and it will be curved.
Outward curve. What about Johan? Did you? Those who finished can draw for like a equidistance. For both equidistance, if it is, take some point x and y, draw for ex equals to ey and ex is more than ey. Draw for both. G1
Sir.
done.
Yes, sir. Sir, I should offer this ex equal to ui, sir, and this ex greater than ey.
Yeah. Did you finish that both positive?
Yes, sir.
Philip?
Sir, once I check it, sir.
Sorry?
Sir, I want to check it, sir.
Yeah. I'll draw it.
Okay, sir.
Anjali, no doubt in this one?
No doubt, sir.
Super. Well, Jafar, no doubt, right? What about Johan?
Sir, can you once again explain these rules, like how to draw this diagram?
Okay, I'll draw for this both like charges, right? See, as we drew above, both are going outward, right? So let's draw outward first. Why I'm drawing this way? Because they are repelling. Even both are going outward, so they are repelling. Doesn't matter you draw anyhow, it will be repelling. Our main concern is this part. This side. This is repelling. Now, similar way, if I draw for both negative, then try for both negative. They both are incoming. So they are incoming, but they will repel at this point. The same diagram, but direction of arrows will be different. Got it, Johan?
Sir, but why are they like incoming? How do you determine outgoing and incoming, sir?
See, actually, it was not like that exactly. Okay, so even this, we say proton and electron, it's nothing, it was nothing like that. We gave a name, we gave a direction for something. Okay, something should flow for determining other things. Even direction of current also we have determined. We have assumed that this is the direction of current so that we can find out remaining things. So we gave that, okay, outgoing charge, higher to lower potential. We are assuming positive as a higher potential, negative as a lower potential. It is actually not like that, but we are assuming for our convenience. Like in lower grades, like 10th standard, we used to have a sign convention for finding lens and mirror. So what we are finding, okay, left side negative. Who said to take left side negative? Nothing, no one. So we have assumed for our other calculation. So to make our things easy, so we gave this one outward force or outward moving direction as for positive, inward for negative. That's what we gave. Okay, so we are following from all these years. Even same for this conventional flow of current is flowing from higher potential to lower potential. So we are assuming here higher potential as positive. It's moving outer current is moving outward from higher potential and inward to the lower potential, that is negative. That is why we have outside and inward direction of these charges. There's no particular reason here. Okay.
Yes, sir.
Okay, draw for this negative. Then I want to go for electric dipole. Okay, how we look at this one? G1, Ax equals to Ey. Take 2 points, X and Y. Yes, G1? You saying something I couldn't? You said something?
Sir, I don't know how to draw this, sir. Ex equal to Ey and Ex greater than Ey.
Take it. Then let's draw. Ex nothing big here. We are just drawing a points. X and Y. This all are this direction electric field. Now, where will be electric field higher, at X or at Y? In this case, both will be same because they are parallel. We know that closer the electric field, strength will be higher. So if I choose point here X, I choose point here Y. So closer the electric field, strength will be higher. It is similar as magnetic field. Electric field and magnetic field properties are almost 99% similar. Even we can say 100% approximate. Few differences we'll see on magnetism. Third chapter. Okay. So can you understand now? G1?
Yes, sir, got it.
Johan?
Sir, here Ex and Ey, what do they represent, sir?
E is electric field at point X. Ey is electric field at point Y. So E, not just electric field, strength of electric field at X and strength of electric field at Y. So here they both are parallel. All electric field lines are parallel, equidistance, symmetry electric field, or whatever it is. So that time we are saying that electric field intensity or strength at X is same as Y. Both are same. Now, on the second case, electric field at X is more than electric field strength Y. Why? Because they are closer at point X than Y. We are comparing X and Y. There can be another point also, but we are comparing here X and Y. So at point X, strength is more as they are closer. So strength of electric field is higher as they are closer. Okay. Next is dipole. Jafar, what is dipole, electric dipole? Jafar, are you with us? Or you went for dining? I hope so. Okay, Varsha, tell me. What is electric dipole?
Two equal and opposite charges separated by a distance is
Some
called.
distance, yeah. And what will be dipole moment, Adesha?
So dipole moment of an electric dipole is having two charges as plus q and minus q. They are separated by the distance 2l.
2L. So product of those will be dipole moment. Okay, let's write here. Okay, do we have this notes at the front? Oh yeah. Yes. Electric dipole. A system containing two equal and opposite charges separated by a finite distance. A system containing two equal and opposite charges. Two equal and opposite charges separated by finite distance. That is called electric dipole. So what is dipole? When there are equal and opposite charges, they makes a dipole. And movement of that dipole is called dipole moment, simple way. They are moving with some axis or some point. So product of Q and 2L or distance will give you a dipole moment. Now why we are taking a 2L? So that L at from point center, this distance L, this distance L, so total distance is 2L. So while taking numerical, if they give distance between two charges, then we should not take L something, they'll give some 2 mm, 2 centimeter or 2 mm, 2 centimeter. Let's take 2 centimeter. That means 2L equals to 2 centimeter. Means total length is equals to 2 centimeter, not L equals to 2 centimeter. Then we will do multiply with 2 and all that divide by 2. No. The distance between them, that is 2L equals to 2 centimeter. Distance between dipole is 2L. Now dipole moment, as we saw, dipole moment of electric dipole having charges of plus and minus q separated by distance 2L is defined as product of magnitude of one charges and distance between them. But net charge on electric dipole is always 0. Why? Because it's plus minus q. So plus and minus will make 0. Same. That's why we said equal and opposite charges. Are we clear with dipole moment?
Yes, sir.
Sir, I didn't get product of magnitude of one charge.
One charge means any one charge. Q, because both values are same only. Both values are Q. Plus Q or minus Q. Both are Q. They are equal and opposite. See, remember that if they give two charges, if both values are same, then only it will be considered as dipole. If both values are different, then it won't be considered as dipole. Then we cannot use this dipole moment formula. Because there will be question like this. It will be confusing. They'll give two charges. But it won't be equal, then we cannot use this dipole moment formula. So Q 2L, product of magnitude of one charge and distance between them. That is your dipole movement. Jivan, are you able to understand now?
Yes, sir.
What about Johan?
Yes, sir.
Anjali, are you?
Yes, sir.
Oh, Divya, you joined at the end of the class. You're busy?
Yes, sir.
Okay. Anyhow, you already saw this video classes, right? You were there in classes, this topic.
Yes, sir.
It's not a problem. Okay. Electric field due to dipole. So electric field at a point P on axis. This is your axis. So it will be same form what we wrote before. So with this, a big different terms, don't get confused with that. Same formula. What we wrote here. Where is it? Oh, it's down. Okay. Same formula on axis. Electric dipole, electric field due to dipole at first one at point P on axis. So it will be E equals to 1 by 4 pi epsilon naught 2p by r cube. This is just formula, remember it. No need for this derivation, let it be. Similar way, equatorial point at center of this one. Equatorial point is P dash is perpendicular to this Q1 and Q, sorry, Q plus Q and minus Q. So that is half of this one, half of the first one. Okay, this all questions you already solved. Okay, those who didn't, you can try this. Yes. Are you trying it? Did you get the answer? Anjali? What's the first answer? First and second? Doing it. Johan? Johan? Are you able to solve?
Yes, sir.
You got the first one?
No, sir.
Okay. Try it. What about G1?
Sir, no, sir.
Okay. So apply formula Q equals to NE. So we have find 10 to the power 14 electrons. That is number of electrons. Then find out Q there. Q equals to NE is 1.6 into 10 to the power minus 19. Use that formula and find out the first one. Similar way do for second one, but we have to do separately because here we have given proton and electron both. So proton value will be plus, electron value will be in the minus. And sum it. That's it. Nothing big here. Adesha, Divya, Varsha, Jafar, no doubts in this question, right?
No, sir.
No, sir.
Jafar? And Varsha?
No doubt, sir.
Because you already know the answer, right? I think so.
Yes, sir.
Okay. What about Anjali? Are you able to solve? Easy. Check it. Check this answer. G1 and Johan are getting same. G1.
1 minute, sir. I'm solving.
Oh, okay. And what about Johan? Check your answer. Okay. Last Sunday, who all gave test? Let me check. Okay. Adesha, Anjali gave, right?
Sir,
Yeah, Varsha also. Fine. And Jafar also gave. Fine. Did you find any difficult question in that? Tough question? Adesha,
Yes, sir.
did you find any difficult question in that? Last test?
No, sir.
No? Okay.
I
good.
already asked which I was not able to do it.
Oh, we already discussed. Okay. What about Varsha?
yes, sir.
Oh, you gave that one test also. Good, good. Okay, do you have any class today? Any other class except this one?
No, sir.
Okay, shall I post a test today? Now? Like for same units and measurement? Like some other advanced topic? Wanna give test for a units and measurement advanced topic? If you say yes, then I'll post it. Yes, guys, tell me. Or you don't want to give a test today? Okay, then let it be. I'll give next test for second chapter. Laws of motion. Okay? Next week. So prepare for it from tomorrow itself. Whenever you get time, prepare for laws of motion. Okay. I'll keep a test on laws of motion for on next Sunday. Okay? Everyone? Is it okay for everyone?
Yes, sir.
Johan, did you finish this? Both questions?
No, sir.
Okay, those who finished can end the meeting. So whenever you get time, prepare for laws of motion. Newton's law of motion.
Thank you, sir.
Yep. Bye-bye. Jeevan, what about you?
Sir, done, sir.
Done? Okay, so you heard right. Next week, next Sunday, there will be test for laws of motion.
Okay, sir.
This week we'll study this chapter only, but for test will be for 11th standard topics.
Okay, sir.
Okay. Okay. Bye-bye.
Sir, now can I leave the class, sir?
Yeah, sure.
Okay, sir.